All right, we just finished discussing the two types of reasoning, inductive and deductive reasoning, and now we're going to focus in on the actual statements that we use when we're doing these different types of reasoning. So this set of notes is going to be called 2.3 Conditional Statements. And if you haven't been able to tell yet, we're going to be doing a lot of writing in this unit. A lot of sentences, a lot of words, not a lot of pictures, not a lot of drawing. So if you like to write, this is your moment, I guess. If you don't like to write, suck it up. So let's start by defining a conditional statement. So conditional statements. A conditional statement. The word conditional means that there are conditions, right? The easiest way for us to think about a conditional statement is that it is an if, then statement. Okay, it's an if and then statement, which is a cause-effect statement. If you do something, something's going to happen. If something happens, something else is going to happen because of that. And what we want to get really comfortable with is the P implies Q idea here. Okay, the P part of these statements is called the hypothesis. And it's always the if part of the statement. So this is the if this happens. And the Q, we touched on this a little bit with the deductive reasoning, so we're going to really get into it today. The Q is the conclusion. And that is the then part of the statement. Okay, so we're going to be working exclusively with if-then statements, and we're going to be determining which part is the hypothesis and which part is the conclusion. So, quick example, if it rains, then your hair will get wet. So if it rains, then your hair will get wet. Okay? In all these statements we work with, the smartest thing that you can do is get as comfortable as you can, as fast as you can, with identifying the hypothesis and the conclusion in every statement. And then what you need to do is train yourself to not care what the words say, to only think of these as these specific pieces. And notice I'm not worried about the if and the then. I'm only worried about the piece of the statement that follows it. And this is where attorneys and people that kind of argue and logic and reason for a living can be so successful, because they don't focus on the words so much as to whether or not you can logically prove it. And we'll give you some examples of that here in just a second. So our hypothesis is it rains. Our conclusion is your hair gets wet. And notice I'm not even writing the words exactly the same, right? The words are not important. It's the event or the action that matters. Okay, so my question here is true. So is this conditional statement true? So the way we're going to look at this is based on the hypothesis and the conclusion. So we're going to look at our hypothesis, and we're going to look at our conclusion separately. So what our hypothesis means is that it's going to rain. So it rains. Our conclusion is that you're going to get wet, or your hair is going to get wet. So what we want to do is break this statement down and see, is it really true or is it false? So let's assume all the different possibilities. Let's assume that it does rain. In fact, it rains, right? And let's assume that your hair does get wet. It rains, hair gets wet. Well, if it rains and your hair gets wet, then that's true. That's a true statement. It happened. But let's assume that it rains, and is there any chance that your hair wouldn't get wet, right? And so a way you can think about that is, well, it rains, but I had an umbrella. So the fact that it rained may have been true, but my hair didn't necessarily get wet. So I would be proving that statement false, right, if I had an umbrella. Now let's go to the rain. Let's say it doesn't rain, right? Doesn't rain, false. We started out false. Well, could your hair still get wet? I think it could, right? So no rain, but took a shower. So does that make our statement true, or does that make our statement false? And we're going to leave that with a question mark for right now. And then let's go look at, again, so let's say it does not rain, and our hair doesn't get wet. So no rain. It's very possible that our hair doesn't get wet, right? We could just have dry hair, or we didn't take a shower that morning. So anyways, we have dry hair. So again, the words of our original statement are really not important. What's important is that we think about what it means to be true and what it means to be false. This is going to be slightly uncomfortable for some of you, but that's okay. Anytime we have a pattern of false true or false false, those are automatically true statements. Okay, so both of these statements would be considered logically to be true, but the idea of the entire statement being true or false is based solely on these patterns here. And we're going to do an example that maybe make a little more sense. I just wanted you to have this little table. This is called a truth table, and a couple little statements to go with it, so you can get an idea of how you can say true and false on these things. It's not complicated. So here's our example. We're going to say if 2 plus 2 equals 5, then 2 plus 3 is not equal to 5. Okay, so let's come down and look at our statement. First of all, this is our P, this is our Q. Now, we have to determine our hypothesis and our conclusion, which part is false and which part is true, and what the overall impact for our statement is. So 2 plus 2 equals 5. Well, that's false, right? So we come over here and it says, if 2 plus 2 is 5, then 2 plus 3 is not equal to 5. Well, unfortunately, that's also false, right? But you have to think about this. If 2 plus 2 is 5, right? So 2 plus 2 is 5. Now we know it's false. We've established that it's false. I get it. It's not 5. But if 2 plus 2 is 5, doesn't that mean that 2 plus 3 can't be 5? Because 2 plus 2 is 5. And so the fact that these are both false makes this a true statement. Now, true does not mean it's actually going to happen in the real world. It just means that we accept the logic here as true. A good example of that is if you've ever watched The Avengers. Okay? In The Avengers, Thor shoots lightning out of his hammer. Now, I bet you've all seen The Avengers, and I bet none of you were watching The Avengers, and when Thor shot the lightning out of his hammer, you stopped and said, wait a minute, that's false. That can't happen. Right? But it is, right? That's false. That's made up. That can't really happen. So that false thing is happening. Now, in the rest of the movie, you have the Hulk, right? He shows up later. Green, big, right? Everything about the Hulk happens. And that's also false. But way back up here, you accepted it. You were like, yeah, Thor lightning, I'm good with that. Let's go. So when the Hulk shows up later, yeah, that's absolutely gamma radiation. I get it. So all of that together, that came out to a true statement, right? That's why you watch the movie, because it's believable, everything's fine, you're good with it, you accept it, it's all true. So just keep in your head that the fact that the statements are true or false, meaning 2 plus 2 equals 5, completely irrelevant. It's all to do with the logic and the patterns, and we're going to practice it a ton. All right, there are 4 types of conditional statements. So the types of conditional statements. Okay, the first type of conditional statement is the one we've already worked with. It's the actual conditional statement. The next type is the converse. There's an inverse, and there is a contrapositive. Okay, we're going to make a little table here. All right, so with these statements, the conditional statement goes if P, then Q. So we literally, when we read that, we say if P, then Q. The converse is sometimes considered to be the opposite of the conditional statement. It says if Q, then P, and that's how we read it. If Q, then P. The inverse is, I'm going to write this small down here because you'll see this word, is the negation of the conditional statement. And we write it like this. Not P implies not Q. And so the way we say that is, if it's not P, then it's not Q. And the contrapositive is the negation of the converse. So it's not Q, not P. So we say, if it's not Q, then it's not P. Okay, all of these statements can be true or false. This one can be true or false, this one can be true or false, and this one can be true or false. Okay, there's no, you have to do what we did on that last thing. You have to read each little part of the statement, decide if the hypothesis is true, decide if the conclusion is true, all that stuff. But something very interesting about these is that the converse and the inverse are always the same. So if the converse is true, the inverse is true. If the converse is false, the inverse is false. And the conditional statement and the contrapositive statement are also always the same. So if the conditional statement is a true statement, you don't have to check the contrapositive. It's also a true statement. And the same goes if they're false. This is a very important concept, and it's called logically equivalent statements. Logically equivalent statements. And they are statements with the same truth value. Truth value just means true or false. So if you're looking back at your notes, the conditional and the contrapositive are logically equivalent, and the converse and the inverse are logically equivalent. So that's it. Have a great day.